Good evening. Kia ora. Hello. Welcome to one more session of the Coding Night New Zealand User Group. And tonight we have a joint session with the Wellington .NET User Group, and we have Xiaodi. Yeah. Hello. How are you?
Hello. Hi, I'm good. Thanks, Matthew. I'm Xiaodi. Nice to meet you.
Yeah. Yeah. And tonight, like, you're going to be talking about running your apps on Dapr. And I don't know if you could just bring like some insights on what you're going to be presenting.
Yeah. Today I'm going to talk about Dapr. That's distributed application runtime. So I'm going to talk about what Dapr is, what it can do, and how to run your application on Dapr.
Nice. Well, while like we have like more people joining, I'd like just to bring some like awareness, like and talk about like the user group, who we are and what we aim to do it. Right. So the .NET, the Coding Nights user group. So we are a community of developers. We love coding, and we try like following best practices as much as we can. Right. And the intent of the user group is to enable developers with like practical knowledge, right? So if you're like a junior developer up to a lead developer, I think we're gonna make like the most from this user group. So we're more focused like on development, and we are part of Azure Tar, which is a community focused on the cloud native implementations. I invite you to have a look at that, and the .NET Foundation as well. So in general, like we present a mix of content, and where we're targeting also some of the projects available on the .NET Foundation. And we have also the Wellington .NET User Group. I don't know if you could mention a little bit about it, Xiaodi.
Yep. Yeah. So .NET on the Microsoft .NET technology. So normally we organize the meetups and events to advocate Microsoft technologies. So recently we have got lots of online events, but in future probably we invite more speakers and have the in-person events soon. But yeah, who knows? That's it. Yeah.
No, that's cool. Yeah, with that, I would like just you to give you the floor and just bring like your presentation. So you could just start. Well, that's it.
Yep. Cool. Thanks, Marcel. Cool. Um, Hello, everyone. Thanks for joining today's session. My name is Xiaodi. I'm a Microsoft MVP. So today, just as I mentioned, I'm going to talk about Dapr. So that is distributed application runtime. So when we talk about distributed application, I think I'm not sure if you agree with this statement. So now the word is distributed. There are more and more distributed microservice applications. So today, I don't think we need to explain too much about the benefits of the distributed microservice. But one thing I would like to emphasize is that even though we have so many services or components in the cloud, there are still some challenges. It's not easy to build a distributed application. So let's say example. That's like a diagram of distributed microservices architecture. We can say that the application has been decomposed across a couple of distributed services. So each service has its database, code, and other dependencies. So it's self-contained. These services normally are deployed in the containers and managed by a container orchestrator like Kubernetes. So we can scale out the services separately. But from this kind of architecture, we can find some challenges here. First, yeah, we might have multiple instances, right, for each service. We need to know where these services are, what their health status. Also, each service should be stateless, but some services must track the state to complete the business logic. For example, if you develop like e-commercial system, like online shop, we need to maintain the user's shopping cart, right? So Some services need to track that. We need to have a state store. Also, we need to decouple the modules. Probably you need to use some event bus, or we say pub sub pattern, to for the services communication. Another thing is that because all the services are deployed in the cloud, probably you need to retrieve the keys or secrets to access some resources in cloud. These keys or secrets are stored somewhere in cloud. Maybe you use Azure Keyword or use AWS Secret Manager, but we need to find a way to retrieve that. So you can see the diagrams looks good, but we do need to handle these common challenges for the distributed microservice. It's not easy. So why the microservice development is difficult? I think one reason is the complexity. Besides the challenges we mentioned before, there are so many different tools or services in cloud. We need to make decisions like which one we'll use. For example, if we talk about the state store, you might use a NoSQL database. You can use Azure Cosmos DB or Redis or AWS DynamoDB, right? So which one should we use? How should we write the code? How do we integrate these cloud services with our application? What if we want to use another platform? Like now your application runs on DynamoDB, but maybe you need to support Cosmos DB, right? How can we reuse the code? The challenge is that if you write the code that targets a specific cloud provider, that means your application will be tightly coupled with that cloud provider, and you cannot easily migrate to another cloud platform. So your service is not portable. It's a like we can say it's a vendor locking risk. Right? Your application or system is locked by this platform. What if we want to implement a state store for the shopping cart service? So that's a very common feature in all online shopping systems. We have many available options in the cloud. You can use Redis, you can use Memcached or MongoDB or Azure Cosmos DB or DynamoDB, right? So some services you can deploy that in like on-premise infrastructure. Some services are hosted in the cloud. So let's assume that currently our client has existing solution in Azure. So we decide to use Cosmos DB as a state store. Then we probably will make it like this. So first, we'll need to learn how to use Cosmos DB. You need to read the documentation and install the Cosmos DB SDK for a specific language. If the project is developed by .NET, I'll need to install the .NET Cosmos DB, .NET Cosmos DB SDK. Then I can write the business logic on top of that. That's quite straightforward. So next, the change could be, what if we want to implement this hybrid cloud architecture? Like we want to support on-premises or AWS. Maybe we need to support the AWS DynamoDBs or Redis. So we'll need to implement the state store for the different implementations. But how can we reuse our code? I think if you have experience with software development, you would say, hey, we can use some design patterns like dependency injection. Dependency injection is quite a common design pattern. We can define an interface to make an abstraction for the common operations like create or delete or get. Then we can have different implementation. One for Cosmos DB, one for Redis. Right. So now we can use dependency injection to inject the correct implementation for the specific purpose. So now it supports two platforms, right? What if we want to support more, right? Apparently we need to write more code. We need to install another SDK. We need to write the kind of similar code to implement the same purpose. It works, but you will find many duplicate code. in your solution. So because you need to install different SDKs. If these SDKs have like kind of conflict dependencies, that would be a nightmare. That's a problem. Um, yeah, so that's a principle in software development called don't repeat yourself, right? As a developer, we don't want to repeat ourselves. We just want to write the code once and reuse it. So we need to find a better way to solve that. Um, I think that now why we have so many changes for developers. Now, the everyone's talking about cloud native, right? The reality is that to be a modern application developer, we need to understand many services in each cloud provider. Um, I'm not sure if you have the same experience. You need to learn Azure, learn AWS. Probably you need to get some certificates. But as a developer, we just want to focus on business logic only, right? We should lean on the cloud platforms to implement the scalability or flexibility, resiliency, maintainability, something like that. So developers should not be expected to become a distributed system expert, right? How can we solve that? How can we just write the code once and reuse that? How can we reduce the cognitive load to support more platforms? So that's a question. That brings us to today's topic, Dapr, or distributed application runtime, which is a new way to build modern distributed applications. Let's say what we can do if we use Dapr to build the same application. Okay, let's go to the next slide. Okay, so this is the same example of the shopping cart service. But this time we use Dapr and we can refactor the system like this. We don't need to install any SDKs. We remove the DynamoDB SDK. We remove like it Redis SDK. We don't need to install any language-specific SDKs for any specific service. We just call the standard API exposed by Dapr, and Dapr will call the underlying cloud services. In other words, Dapr is like an interface, right, or abstraction layer between our application and the cloud services, which can reduce the complexity. If we want to support more cloud services, no need to change the code. Just update the configuration file of Dapr. That says application now is portable. You can easily run the application on any cloud platform. Also, the code will be simple, will be shorter, and easier to manage. So that's just an example of state management. That's just one feature of Dapr. And let's say more detailed Dapr. So if you have any questions, you can send your comments, and if I look that, I can answer the question. Cool. Next. Okay, so Dapr is trying to solve the complexity of building a distributed application. So here is the overview of Dapr architecture. You can see on the bottom area, you can see the cloud providers, Azure, AWS, Google Cloud, Kubernetes or on-premises infrastructure. In the blue area, there are some building blocks of Dapr. Now we have a new term, building block. What is a building block? A building block is an abstraction layer for a specific cloud capability. Or we can say it encapsulates a distributed infrastructure capability. For example, the state management we mentioned before. If we use Azure Cosmos DB or AWS DynamoDB, you would find that there are lots of similarities between them because both of them are just NoSQL databases. So on top of that, Dapr provides a building block to make an abstraction for this capability. Then we can access this capability through the Dapr API. It might be HTTP API or gRPC API. So on top of this layer, we'll have our application code. That's our business logic. Because Dapr is language agnostic, so you don't need to worry about what language you can use. You can use any languages. You can use Python, .NET, Go, or Node.js, Java. Yeah, they all call the Dapr API through the standard HTTP API or gRPC API. There's no hard dependencies to those cloud services. Yeah, let's look at the building blocks. So besides the state management, there are some other building blocks. For example, the service invocation, service to service invocation, and pops up. It's like a message queue, right? And the bindings, actors, observability, and secrets. All of these building blocks, they are based on the cloud native service. So today I'm going to show some demos for state management and secrets and service to service invocation. We won't introduce each of them, but we can understand that Dapr allows you to swap out different underlying implementations without having to change the code. So this way, in this way, your code would be more portable, more flexible, and vendor neutral. So the question is how it works. This diagram shows a Dapr architecture, which is called Sidecar architecture. It's like a sidecar you can assemble with your motorcycle. A sidecar enables Dapr to run in a separate process or a separate container alongside the service. For each service, you can have a Dapr sidecar. So one service, one sidecar. Dapr will not intrude on your application. So it will be easy to change the code to adopt it. In this diagram, we can say your service calls the Dapr sidecar through the HTTP or gRPC API, and the Dapr building blocks invoke the components that are on the bottom row. So we have two components. We have a new term now, another new term called component. What is a component? A component is to provide the concrete implementation for the cloud service. So now we have two components. One is Redis Cache, one is Azure Service Bus. So how do we understand their relationship? If you have the experience of OOP, the programming, solid principle, you know the interface. Yeah, if you have the basic understanding, we can think of that as the building block is like the interface, and the component is like a concrete implementation. So that when we call the interface, you don't need to worry about implementation. You just configure that to call the correct concrete service. The application doesn't know how Dapr calls these components. It just needs to know the interface, like the building block. So there's no dependence between your service and the underlying cloud service. Because all of these building blocks, they are independent, you can use one or use many of them. You can use one building block or use many of them. It just follow your requirements. Okay, that's how it works. And let's say, what components do we have now? Dapr now has a set of components for many popular services. For state store, we can say it supports DynamoDB, CosmosDB, Firebase, Redis, and Cassandra. Similarly, the other building blocks also have many components. Most of them are popular cloud services. There are over 70 components available now. If you need to support another service, you can just update the Dapr configuration file to support that. No need to change the code. So it's pluggable. Also, Dapr is open source project. So everyone, you can create components for any resources and contribute the code. Yeah, that looks cool. Yeah, let's say example of state management. So later I'll show a demo, but let's see how it works. Here's a detail of the state management. Now we have the implementation as Redis cache, right? We can send a post request to save the state. If you can see the URL, that's a standard API. no matter you use Redis cache or DynamoDB or CosmosDB, we use the same API. That's a common interface between the cloud service and our application. So we can
So
post the message.
so in this case, because you're dealing with state, so would be always the same sort of path, like v1 state and what you have, because it's specific for state.
Yeah, that's specific for the state. Yeah, state management. If you need to access the other building blocks, you will use the other APIs. Yeah.
Cool.
So now we post a JSON file and we save it in the Redis cache. So if we want to retrieve that, we will send a GET request. We can send a GET request. That's probably the state K, and use that's also a standard API. So next, let's say if you want to use a CosmosDB as a state store, we don't need to change the code because the request is just a standard GET or POST request, but we'll just update the configuration file for Dapr. You can use CosmosDB, Redis, or MongoDB, or any other cloud service. So we just plug in the CosmosDB, then you don't change any code, then it works. So we say the application now is pluggable, it's portable, it's vendor neutral. Also, a huge benefit is that as developer, you don't need to manage the difference between different cloud providers. Imagine that if you want to access a DynamoDB, you need to understand the APIs of DynamoDB. You need to install the SDK. But when you use a CosmosDB, you need to have another SDK. You need to read their documentation. So probably they have some difference between these SDKs. But if you use Dapr, you can use a standard API. Just call it. So we have mentioned a couple of times we update the configuration file. So what is a configuration file? It's actually just a YAML file. It's like that, like the Kubernetes config file or Docker Compose, something like that. For example, this is state management configuration file. So for this file, we can say the type field is state the Redis as the state store, right? And also we have some metadata. You can see we specify the name, the value, the URL, and the name, username, and the password or secret. If you want to use CosmosDB or DynamoDB, we just update the configuration file. So now we use the type as azure.cosmosdb. And also we'll need to update the metadata because different annotations, they have different configuration fields. For CosmosDB, we need to specify the URL and the secret key and the database name and the collection name. So it's related to your cloud service. But no matter you use CosmosDB or Redis, the Dapr state API, they are the same, right? You just if you save the state, you just call this API. If you retrieve that, you just call that. So your code doesn't care what the implementation is. Right? It's standard API. Also, you will not notice that, for example, the last slide, when we use the secret key, you will say we don't have the hard-coded key here. Instead, we'll reference secret key in the Dapr secret store because we don't want to have the key or secret in the configuration file. It's not safe. We have mentioned that Dapr has secret store building block, so it can represent the application to retrieve the key or secrets stored in your like secret managed system, maybe your Azure keyword or AWS secret manager is another abstraction layer. So now we just use a reference. Right? I'll show a demo later. You can see this also use a secret key reference. Right? Just specify the key name and the Dapr secret store building block will retrieve the key for us and apply it here. Okay, so yeah, next, that's how we use the Dapr SDK. We mentioned that you can call the Dapr API directly through the HTTP API or gRPC API, but for convenience, Dapr also provides SDKs for various languages. So, for example, if we say you use a .NET SDK, you just create a Dapr client instance and call get state method, get state async, specify the state name, state store name, and key name. Then Dapr will handle everything. You don't need to know where the state store is, right? So everything is configured in the configuration file. Yeah, that's how we save a state.
Xiaodi, we got
Okay.
like a question from
Mm-hmm.
Jeremy.
Yeah.
I just bring like on the channel, but like
Okay.
the,
Let
the
me.
scenario he's mentioning here, where you let's imagine like if you are swapping state providers, does Dapper have a way to easily migrate the existing data from one provider to the next? I think
Yeah.
he
That's
meant
that's
he
yeah.
meant like if you have like a state on, I don't know, on a storage and then you're moving to Cosmos. Is there like any easy way of doing that?
Yeah. That's a good question. I think that's from my demo. I didn't implement that. I think it's basically do we want to persist the state for I mean always persist the state because the shopping cart is um, like a temporary state. So if we it's rarely you switch the implementation very often. So
Hmm.
I think maybe we need to manually handle that. But if you want to migrate the data from between different state stores, I think we need to manually do that. Dapr will not do that step. Yeah, I'll show you a demo now. Let's see how we switch out the state store. Okay, I'll just on my VS Code. Okay, cool. So let's say a very simple application. That's a console app. If you look at my screen, yeah, I think you can look at my code. So that's console app. So what we do here is create a Dapr client, and we try to retrieve the state from the state store, and we increase the number and save it per second. So when we install Dapr locally, you will see my Docker desktop. So after you initialize the Dapr runtime, you will see Dapr has a built-in Redis instance. It's called Dapr Redis. Um, it's a local Redis instance, but you can also replace later. So now we will use this Redis instance as a state store. Um, you can see we just create Dapr client instance and get and save, but we don't have any dependencies to Redis. Right? We just reference the Dapr client. So Dapr client will handle the difference for this implementation. We just use Dapr client. Um, you might want to know where we configure the state store. So I'll show you. Um, if you look at your .dapr folder, there's folder called components. In the components, we can find the configuration files for the building blocks. For example, if you check the state store YAML file, okay, that's the configuration file for state store. You can see we specify the state.redis as the state store. We have the URL localhost and username and password. So that's that targets to this Redis instance. Okay, we can say if you click that, you can go to the can you see the Yeah, we can type. We can call the Redis CLI to list all the keys. I think we could use case. Yeah. So now it shows empty array. So there's no case now. So let's try to run the application and see what will happen. Okay. So if we run the application. So when you run the Dapr application, you need to specify the app ID. So app ID is like the ID of your application in the environment. You need to specify this field. And we'll run .NET run. That's .NET command. Then we press enter. So it will build application and also start a Dapr sidecar. So you will see now it works. So counter 0, 1, 2, 3, 4. It will increase per second. And if you check the key again, you will see we have a key called Dapr counter. So Dapr counter is app ID, and the counter is the key, right? So that's the key of the state. So now if we Control plus C stop that, the state is already stored in the Redis. So you can see now the value is 30, right? If we run the application again, you will see the number increase from the last state. So that means the state store works. So the next thing I want to introduce is how we can switch to another implementation without changing the code. Let's say I want to use CosmDB, right? How do I do that? So I think I created CosmDB instance in my Azure subscription. So it's here. Okay, that's Azure CosmDB. If you look at the Data Explorer, we can create a database, create a collection, and we also have the keys, right? We have the keys, primary key or secondary key. So next, I'm going to show you how to connect to this CosmDB instance. I already prepared some configuration files. So if we look at this CosmDB YAML file, okay, so that's an example of CosmDB configuration file. So here we specify azure.cosmdb and the URL, and copy this file and paste in the state store YAML file. Okay, I'll save it. So that's how we plug in another implementation, right? Replace the Redis implementation. So now I'm going to run the application again. Let's see what will happen. Okay, you will see the number is not from 40, it's from 200 because I already have some data in my CosmDB. Okay, so yeah, my CosmDB has you can find the data here. That's this, yeah, that's the data I already have here. Dapr counter, right? That's the same same key with the Redis implementation. You will see the value is is encrypted, so it's not a number. Okay, so now we already switched to the Azure CosmDB, but you will see the problem is that we have a hard-coded key here. That's not safe, right? We don't want to put the key in the configuration files. If you remember what I mentioned before, we have a secret store building block, right? Let's see how we use that. To store this key safely, we can have key vault instance. So I already created a key vault instance, Azure key vault. Azure key vault is a safe place to store your secrets or keys. So now I created key vault and store the secrets in the secret menu. So you can click that. That's the key. Right. Yeah, that's a key, and already put the value in this field. So remember, the keyword is safe place, but we'll need to grant the application to access this keyword. So if you would like to make the same demo, we all need to set up the access policies. So I already created a service principal to represent our application, the Dapr application, to retrieve the key. If you look at that, you can see I created a Dapr application, and it has a get permission, right? I'm not sure if you are familiar with like service principles or permissions. So that's part of Azure infrastructure. So with this way, we already have Dapr application that can access the keyword. So next, let's configure that. So next, I'm going to create a state store. I already have an example here. So I have an Azure keyword YAML file. Okay, so this one is the secret store I mentioned before. You will see that's the type is Azure.keyword, and the metadata we need to specify the vault name and the Azure tenant ID and the client ID and secret key. So these IDs are from the service principle. I will publish a blog to introduce how to configure that, but you just just know the Dapr needs a service principle to access the Azure keyword. And also another question is that you might wonder why we have the secret hard-coded here, because it's just a demo, so I put the secret here. But if you want to keep the safe, you can install a physical certificate on your server. So this is just for demo purpose. It's not the best way. So now we configured secret store, and next we can use the secret reference in the state store. So I have another example to use the keyword. So I'm going to use this one, paste it in. Yeah, I'll paste it here. So the last version we used a master key. That's a hard-coded value. This time, I will use the secret reference. You will see the auth. The secret store is Azure keyword, which we defined here, right? That's the metadata. The name is Azure keyword. And for the keyword, we specify the URL and the key reference. That's basically the key we defined in our keyword. Right? That's a key name, Dapr state store key. So that means you will get this key from your Dapr building block. And that's a database, Dapr API, collection, Dapr state store. Yeah. So in this way, we remove the hard-coded key and we use the secret store. If we run the application again, you should be able to say the application works as expected. Right, it works. So you can see we switch the different implementation easily. You can just use this one or use that one. We don't need to change any code because in our code, we don't have any dependencies to Redis or CosmDB or DynamoDB, whatever. I don't need to worry about that. Just use Dapr to call that. and you don't even need to know where the state store is, right? In your code, you don't need to specify, right? Just to specify the store name, right? The store name is state store. You define it here, right? So everything just configurable. You can just configure that in the YAML file. Okay. Yeah, that's the demo for state store. Next, I'm going to share a demo for the service invocation. If you have any question about the state store, you can post your question in the comments.
Just got a question
Mhm.
about like the key vault. So you had
Yeah,
that already set up. You mentioned like with that particular key that was hard coding there. You mentioned that there could be like a certificate that we could use
yeah,
to replace rather than hard coding that's
right,
on the YAML, right?
right.
I don't know if you have explored that how that could be done.
Yeah, needs to you need to create a certificate on your server. So on the server, when you deploy that, so here you might use I forgot the field name. It's like something like certificate. And here you need to specify the path on the server, like
Yeah,
yeah, the path to the certificate, because the certificate can only be installed on your server, so it should be safe.
yeah.
Yeah, in this way we can. I didn't create that because yeah, I don't have the. I think you need to have some special permission to create certificate. Maybe buy a certificate from some organization.
Mm-hmm.
Yeah,
Okay,
yeah,
just awareness that that's possible as well.
yeah. It's possible. Yeah. So here,
Cool.
yeah, we don't often put the secret in plain text here,
Yeah,
but it's just for demo purpose. Okay.
cool, cool.
Yeah, thanks. So next, I'm going to share a service invocation demo. Um, it's basically a simple web API and front end application. So if you say the backend API is a very simple API, it just generates some random weather forecast data. And for the front end, that's where we use the Dapr service invocation. So for the front end, you will say we create Dapr client, and we just call invoke method async. You don't need to specify the URL of the endpoints, and you just specify the app ID. Right? The app ID is my backend. So where we configure that. So this demo, I use the Docker Compose. It should be easy to understand the relationship between this front end and back end. So for the front end, we specify the app ID as my front end. For the back end, the app ID is my back end. So you see that's the sidecar. Okay, when you run the Docker image, when you Docker containers, this is front end, this is front end sidecar. So one service, one sidecar, one service, one sidecar. Right? The sidecar will run alongside your service. If you run it in the Kubernetes, then they should be running in the same pod. Um, so that's when we call the service. You just call Dapr client invoke method async, but you don't need to specify the URL of the endpoint. Just specify the app ID. So Dapr will automatically find uh, the URL or the endpoints of your service. That's a benefit. So it
Yeah.
significantly simplify the development. Right? You just call the API. You don't need to worry about where it is, what the state it is. Right?
In this case, like, is Dapper going to use HTTP or gRPC for
Uh,
communication?
so when we call the API, so Dapr, when the Dapr building blocks communicate with each other, they will use gRPC by default. Um,
Hmm.
yeah,
Ah, cool. So that's going to be enabled by default.
yeah, it's enabled by default.
Ah, cool.
Um, let's run the application. If you run the Docker image, Docker compose, you will see in Docker will start um, 4 containers. One is front end, back end, and back end sidecar and front end sidecar. So it's all running. And if you run that, you can see where is my browser? It should be here. Yeah. So that's the application. It's running. Every time we refresh that, you will see different weather forecast data. Um, so that's how we call the service through Dapr. You will see you don't need to create a HTTP client or call, you pass the endpoint URL. Everything you don't need to worry about that. Just call invoke method async. What method you want to call? It's a method name. If you want to post something, you might need to uh, have a JSON file, JSON data as the request data. You can see there are many methods, override method, request data or something like that. So it supports the common methods, all the HTTP works. That's the service to service invocation. Let's come back to the slides. Do we have any question for these 2 demos?
Not in particular about the demo. I don't know if you have the GitHub on the link to the source, so people could
Source code?
just have a look and explore.
Yeah, sure. I can upload it to GitHub. I haven't done that because I just created a couple of days ago. I can upload it, and once it's done, I can share it in our meetups. Okay.
Ah, cool, cool.
Yeah. Cool.
That's great.
Yeah. So next, let's see the observability. So Dapr also has a built-in observability of Dapr. The built-in observability. The system information used to gain observability is referred to telemetry. It contains 4 categories, like tracing, distributed tracing, or metrics, logging, also the health check. So I think the thing we need to understand is that Dapr used a standard format of the metrics. It's called open telemetry. I'm not sure if what monitoring system you use. So many systems use the open telemetry. You can publish to different systems like Zipkin, Azure Application Insights, or New Relic. So there are some, just it's follow the open telemetry format. Another thing we need to keep in mind that is the observability is configured at the Dapr system level, it so when the service are built, they just produce the telemetry for the Dapr system services. The telemetry from the application. For example, you want to send logs or monitoring the data from your application, then you need to manually do that. But Dapr observability just to contain the traffic between the Dapr sidecars. So that's the observability. I don't have demo for that, but I can share some links after the session. Dapr supports 2 hosting environments. For local development, we can use self-hosted mode. In this mode, just like the demo I shared, microservice and Dapr Sidecar run in a separate local processes. You don't need to use container orchestrator like Kubernetes. Dapr also supports Kubernetes in this mode. Dapr and your application, they run the same pod, but they run in a separate container. One service for one sidecar. Okay, so next thing, I think most of developers would have concern about the performance. We often say there's no silver bullet. Dapr provides lots of benefits, but I think, yeah, that's a question is because for each service call, we all need to send requests through Dapr Sidecar. Will it impact the performance of the application? I actually have the same concern. What I know is the Dapr team has invested a lot in performance optimization. We mentioned that when you call Dapr API, you can use HTTP API or gRPC. Right? So gRPC is a high performance protocol, and it uses binary payload, which is much smaller than JSON payload. So the communication between Dapr sidecar is always made through gRPC. So from the official documentation, it mentioned in most cases the additional overhead should be like negligible, maybe sub millisecond. I don't have any metadata at hand, but it may vary for different scenarios. Um, to improve this performance, the recommendation would be we use the gRPC as a default protocol when we call Dapr APIs, because Dapr API also has its limitation. Um, Sorry, I mean gRPC. Yeah, gRPC also has its limitation because most of browsers now they don't support gRPC. So gRPC is suitable for service-to-service invocation, but not suitable for end users. But when we develop the microservice, when you call the other services from another service, it's highly recommended use gRPC.
Yeah. That's a good point. Yeah, you're right. Service to
Yeah,
service, gRPC is the way. Yeah.
right. Yeah. Yeah. So now, if you use gRPC, that should be good. Um, cool. That's some resources. If you want to learn more, you can take a screenshot or um, type these links. Another thing I mentioned that I would like to mention that is Dapr provides lots of benefit, but the question is, what if you want to use a specific feature of like any specific cloud provider? For example, you want to use a very special feature of Cosmos DB. How would you use it in Dapr? So the answer would be the purpose of Dapr is to provide the most common operations or features for cloud um, components. It's not to support everything. If you want to use a specific feature, then you have to integrate the native SDK, and you cannot use Dapr because when you use a specific feature, that means your application must couple with this cloud provider. You cannot migrate, right? So Dapr is just to abstract the most common features. It's just to help your application, like you can migrate between different platforms, but it cannot support everything of like all the all the cloud providers. So that I think that's a limitation. So many developers have the similar question. I read some documentations and watch some videos. So I think that's Dapr support everything. Yeah.
Yeah.
Yeah, I think that's basically what I want to share today. Yeah, and thanks everyone for joining today's session. If you have questions, we can have a discussion. Yeah, and
Yeah.
welcome to contact me on LinkedIn. Yeah, thanks.
Oh, that's great. Uh, I was like exploring Dapper for like some time, but it feels like those connectors, right? The underlying services. Well, let's say like the state for storage or talk about Cosmos. If there is, because it's open source, right? If there is any need for you to use a different service that's not supported, you could write some sort of implementation for that, right? So
Yeah, yeah, it's
that's
open for contribution. Yeah.
yeah, that's good. Yeah, really happy. Let's see if we have like any more questions. But yeah, that was a really nice presentation, uh, Xiaodi. Yeah.
Yeah, thanks.
Let's give like one more minute. More questions come up. Let's see. Oh, cool. Yeah, I think like we are fine. So people just like uh talk mentioning here, right? Okay, great talk. Yeah, just I would say thank you again,
Yeah,
Xiaodi,
thank you.
for the presentation and for
Yeah,
the Wellington .NET User Group. That was a joint session with Code Nights. I hope like in future we have more sessions like that.
yeah,
It's just open, right, for anyone
yeah,
really that would
sure.
like to present as well. So just ping me, or it could be like directly on
Yeah,
the Meetup or on LinkedIn, and then we just arrange like a session and we just expose like anything really that if you have available to share with other devs. Yeah,
yeah, cool. Thanks, Marcel. I'm happy to co-organize this event. Yeah, cool.
yeah,
Thanks.
that's great. Yeah. So thanks again, Xiaodi. Thanks
Yeah,
for everyone that joined the session. This is going to be recorded and it's going to be available on the Coding Nights channel, right? So you can check that one later as well.
cool. Thanks, everyone. Thanks
Cool.
for your time. Goodbye.
Thanks, guys. Bye.